Okay, good afternoon, class. Okay, so today we're looking at the examples for exercise 6.9. And 6.9 is on exercise, it's on page 214. Okay, that's basically what the cos graph looks like. The full lesson can be found in the description box below. Okay, I'm looking at example 1. Example 1 is on page 212. So the question says solve for x. I'm going to move a bit faster through this here. So we spent a lot of time on explaining 6.8. The only difference here is the quadrants in which you tick. Okay, well, in the sign quadrant, the sign is positive in quadrant 1 and 2 and negative in quadrant 3 and 4. For cos, it is positive in quadrant 1 and 4 and negative in quadrant 2 and 3. So that's the only difference when it comes to the cos graph. That's why I said I'm going to go a bit faster through it. And as time does not permit us to again spend too much time on it. So cos of x is equal to 0,893. For x is an element of negative 270 to 180, correct to one decimal place. So where do we start? We start by getting the trigonometric ratio on its own. Is it on its own? Yes. So I can work out my reference angle. So I say arc cos now, not sine because I'll be busy with cos. Arc cos of 0,893. We put that in the calculator. Arc cos of 0,893. Gives an angle of 26,7. And this is one decimal place. So it's 26,7 degrees. So which question comes to mind? In which quadrant is cos? Positive. And in which quadrant is cos positive? 1 and 4. So how do we get into quadrant 1? It's just going to be the angle. So x is equal to 26,7 degrees plus k times 360 degrees. Why? Because the time taken to complete one full cycle on the cos graph is 360 degrees. Okay. So that solution is repeated every 360. Alright, so there's nothing we need to do there. Or in quadrant 4. How do we get into quadrant 4? 360 minus. So x is equal to 360 degrees minus 26,7 plus k times 360. So you put in a calculator. 360 degrees minus 26.7 gives us 333,3 plus k times 360. People, that's unlike them. So for those of you wondering why I'm not adding them. Alright. And here we add, what must we not forget? That k is an element of integers. By saying it once, it suffices for both branches. Okay? It's enough for both branches. But have we answered their question? They have given us a restricted domain here, as you can see here. So where do we start? We say x is an element of, and we start listing. We start with 0. If I put 0 through here, what do I get? 26,7 degrees. If I'm going to put 1 through here, it's going to be a value over 360. Is that inside or outside? Outside. So am I going to write that value down? No. So 1 doesn't work, 2 won't work. So now we check negative 1. So 26.7. Some of you will already see that it won't work. But let's act dumb and say, okay, let's check. But we don't know. So it's 26.7 minus 360. Gives us negative 333,3. Is that inside or outside? Outside. So I'm not going to worry about that value. So what do? I go on the other branch now. If I put 0 in here, what am I going to get? 333,3. Is that inside or outside? Outside. Do I need that? Would 1 work? No. So what do I do now? I put negative 1. it's going to be 333,3 minus 360. Gives me negative 26,7. That is within that given domain. If I'm going to go with minus 2, which is 2 times 360, it's going to give me an answer of negative 386,7. Is that inside or outside?
Outside.
Do I need to write it down?
No.
Then there are 2 solutions that satisfy that given restriction. Okay. Let's go to example 2. Example 2 is also on page 212. Here we are given 2 cos x equal to negative 1,456 and x is an element of negative 360 to 360 degrees. Correct to one decimal place, we need to solve for x. So where do we start, people? We start by getting cos of x on its own. So cos of x is equal to negative 1,456 divided by 2. So it's going to be negative 0, negative 0,728. So what do I do now? Half cos both sides. So what do we do with the negative? We drop the negative. Okay? So we got half cos of 0,728. So half cos of that answer. Remember, we're dropping the negative. So it's 43,28. Alright, so what do we do now? The question we ask ourselves, in which quadrant is cos? It's cos negative. We just checked just before we have taken the half cos into account. Okay? In which quadrant is cos negative? 2 and 3. How do we get into quadrant 2?
180
So x is equal to 180 minus 43,28 plus k times 360. So that gives us 180 minus 43.28. Give me 136. Comma 72 plus k times 360. Or in quadrant 3, x is equal to 180 plus 43,28 plus k times 360. Gives me 223,28 plus k times 360. What must I not forget? You say k is an element of? Okay. Have you answered the question? No? They wanted within that given domain there. Alright. So what do I say? X is an element of? And wherever we see a k, we'll then start at that point where k is equal to 0. So put 0 in here, it's going to be 136,72. What is within that given domain? We're going to add 360 to this. It will be over 360 degrees. So we check on the other side, so it's 136,72 minus 360. So negative 223,28. Okay. I'm going to put negative 2 in, definitely is going to be outside. Which is negative 583,7. 28. It's far below negative 360. On the other side, we put 0 through here. Of course, it's going to give you 223,28, which is within that given value there, the restricted domain. But I'm now going to put in 1. It will be over 360. However, if I put negative 1 in, so it's going to be 223.28 minus 360. They give me an answer of negative 136,72. I'm going to put negative 2 in. It will also be way below negative 360. Okay? And there's your solution for that given value. With a given question. So the next one, number 3. Number 3 is on which page? Same page. The question again says solve for x for 2x cos 2x is equal to 0,123 for x in an element of negative 182.90. So when we start, we need to get the trig ratio on its own. Is it on its own? Yes. So I can now go R cos. So we say our reference 2x is equal to R cos of 0,123. Okay. That now gives me an angle of R cos of 0,123. Your 82,94. 93, sorry. I work with 1 decimal place. So it's going to be 82,9. Okay. So again, we do not divide by 2 people. We do not divide by 2. We first need to take it to the quadrant. So the question we ask ourselves, in which quadrant is cos? Positive. Quadrant 1 and 4. How do we get to quadrant 1? Just the angle. Okay? So quadrant 1 is going to be 2x is equal to 82,9 plus k times 360. Now I divide by 2. It gives you 41,5. Okay, just check it. Should be correct. Divide by 2. Now 41,5 plus k times, remember I'm dividing 360 also by 2. The period now goes to 180. Or quadrant 4, how do we get in quadrant 4? 360 minus. So 2x is equal to 360 minus 82,94 plus k times 360. Which now gives us just wrap this one up, 360 minus 82,9 and then divided by 2 gives you 138,55 from 6 plus k times 180. The k is an element of integers. However, it is a restricted domain here. So we say x is an element of, and we start listing. But put 0 in here. 41.5 degrees. If I'm going to put 1 in here, it's going to be over 200 outside. If I put minus 1 in, so 41,5.
Your attention please, all choir notes and please meet in the prefect. All choir notes, please meet in the prefect.
Negative 158.5 degrees, which is inside. If I put minus 2, it will be outside. If I put 0 in here, it's going to be 138.6, which is outside. So I'm not going to bother with that. However, 138.6 minus 180. Or I say plus 1, negative 1 times 180 gives us negative 41.4. Okay? We're going to go with minus 2, definitely outside. People for homework, I would like you guys to do exercise 6.9, the odd numbers. Okay, good afternoon. Okay, so at this point, lesson yesterday, we've concluded the examples for exercise 6.9. However, we didn't do number 3, number 4. Is that correct? Okay. So we're going to look at number 4 and then we're going to discuss problems that you had within this exercise. Okay. This is example 4. On page 212. Sorry? Okay. So what we have is 2 cos of 4x minus 40 plus 3 equals 4, where x is an element of negative 90 to 180 degrees. Okay. So what we do first is we do the general solution. Alright. So our first step is to get cos of the angle on its own. So I take the 3 over, so 4 minus 3 is 1, divided by 2. So cos of 4x minus 40 is equal to R. This sum could well have read without the use of a calculator. Okay. So importantly here, if it read without the use of a calculator, we know that that is coming from the 30-60 degree triangle. This is 1, 2, root 3. So where is cos a half? Where is cos a half? For 60 degrees, because that cos is adjacent of hypotenuse. Okay, so my reference angle is going to give you 4x minus 60 is equal to 40, sorry. Is going to be equal to 60 degrees. Okay. Otherwise, you could have also said arc cos of half, which should also have given you 60 anyway. Okay. So what happens? The question you should ask yourself, in which quadrant is cos? Positive. We always look at the point just before we took our arc sign. Okay? Or arc cos in this case. So in which quadrant is cos positive? Quadrant 1 and 4. So let's go with quadrant 1. The quadrant 1 is going to be 4x minus 40 equals 60 plus k times 360. Or in quadrant 4, how do you get in quadrant 4? It's going to be 4x minus 40 equal to 360 minus 60 plus k times 360. Why k times 360? Because the period on the cos and sine graph is 360. We take that over, so 4x is equal to 60 plus 40 is 100 plus k times 360 divided by 4. So x is going to be 25 plus k times 360 divided by 4, 90 degrees. So the period on this graph, on the 2 cos 4x minus 40 graph, is going to be 90, as you can see. The time taken to complete one full cycle is 90 degrees. Okay, in the quadrant 4, we take that over. So 4x equal to 360 minus 60, 300 plus 40 is 340, plus k times 360 divided by 4 is also 90 degrees. Where k is an element of integers. Oops, I divided it too early. We're going to be 360 divided by 4. So what's 340 divided by 4? 85 plus k times 90 degrees. Where k is an element of integers. Okay. But did they ask for general solution? If they had asked for general solution, I'll stop here. But the question was for x in element of negative 90 to 180 degrees. What do I do? I now list, say x is an element of. I then substitute 0 in there. And that is why we say k is an element of integers. The values is going to be 0, 1, 2, 3 till infinity. And minus 1, minus 2, minus 3 to negative infinity. So that will be 25 plus 0 times 90. We know that's going to give you 25, which is within that given domain. So 25 is my solution, first solution. Then I substitute 1 into k. Okay? This gives you 115. Is 115 inside or outside? Inside. So it's 115. If it was outside, I would never written it. If I put 2 in there, it will definitely be outside. So if 2 doesn't work, so wouldn't 3 and so on. So then I would put negative 1 in. Negative 1 gives me negative 65. Is that inside or outside? Inside, so it's negative 65. If I'm going to put negative 2 in there, you'll see it will be outside again. So would I write that down? No? So this branch is exhausted now. You have used all these solutions there. Let's go on the other side. Of course, if you put 0 in here, I'm going to get 85. I'm replacing k now with 0. So I'm going to get 85. 85 plus 90 is 175. If I put 1 in there, so 85 plus 1 times 180. So, 90, sorry. So it will be 175. Okay. If I put 2 in here, then it will definitely be outside. Can you see that? So what do? I put now negative 1. Okay, which gives me an angle of negative 5. But if I put negative 2 in, oops. Negative 95. So that would be outside. So those are my values. Okay. Is there any confusion? Any questions? Alright, now coming to the sums that you guys had for homework, which is exercise 6.8. No, 6.9. So any issues there? Any issues with exercise 6.9? No, you had to do all the odd numbers there? Okay, so there's no issues. We'll just carry on there with the examples for exercise 6.10.